Hello everyone, myself Hans. Today we are going to solve the given problem based on partial differentiation. Let's solve the problem. Given x की power x into y की power y and into z की power z is equal to c, and condition is given. We have to show that del z upon del x del y is equal to minus of x log e to the power ex the whole power of minus 1 when condition is given x is equal to y is equal to z. Function is given x की power x and y की power y into z की power z is equal to c. Then the condition, if x is equal to y plus z, then we have to show that del 2z upon del x del y is equal to minus of bracket x log ex की whole power minus of 1. Let's solve the problem. Given function taking log both the sides, that is log of x की power x, y की power y and z की power z is equal to log c. We know the properties of log m into n is log m plus n. So we have to write the using property of log, that is log of x की power x plus log of y की power y plus log of z की power z is equal to log c. Again the using of the property of log एक m की power n, that is n log m. So we have to further proceed, that is x log x plus y log y and plus of z log z is equal to log c. This is the function given. Here x y is the function of z. Let this is equation 1. Equation 1 partially differentiating with respect to x and treating y as a constant. Here the xy is the function of z. So when we partially differentiate with respect to x, treating y as a constant, we have to further differentiate, that is using the first second formula, that is taking first is x, differentiation of second function, that is 1 by x plus of differentiation of second function that is log x and differentiation of first function, that is x, is 1 plus here is also, that is taking z is the first function and differentiation of log z is 1 upon z and del z upon del x plus of differentiation of log z and differentiation of again z, that is del z upon del x is equal to 0. Further we have to write, that is z is cancelled and x to x is cancelled, then the remaining is 1 plus of log x, and here is 1 plus of log z, taking common del z upon del x is equal to 0. And from here we have to find the value of del z upon del x, that is del z upon del x is equal to 1 plus of log x is taken into right hand side, that is minus of 1 plus of log x, and the once again, and 1 plus of log z, 1 plus of log z into del z by del x. Further we have to write, that is del z upon del x is equal to minus of 1 plus of log x upon 1 plus of log z. Further we have to find del 2z upon del x, del 2z upon del x del y. Further we have to differentiate equation 1. Equation 1 partially differentiating with respect to y, treating as a x as a constant, x is a constant, that is x log x is 0, and taking y log y differentiating, that is using y is the first function, differentiation of second function, that is log y, that is 1 upon y, and plus of log y, and differentiation of second function, that first function, that is y, that is 1, plus of z is the taking z is the first function, and differentiation log z, that is 1 upon z, and del z upon del x, plus of log z, and differentiation of z with respect to y, sorry this is y, differentiation of z with respect to y, that is del z upon del y, and log c differentiating with respect to this log c is constant, that is 0. From here this is also y, and z to z is cancelled and y to y is cancelled, then remaining is 1 plus of log y, plus here is 1 plus of log z, and taking del z upon del z is common, del z upon del y is common. Further we have to find the value of del z upon del y, that is 1 plus of log z into del z upon del y is equal to 1 plus log y is taken to right hand side, that is minus of 1 plus of log y, and further we have to 1 plus of log z is taken to denominator of minus of 1 plus log y, that is del z upon del y is equal to minus of 1 plus of log y upon 1 plus of log z. Further we have to show del 2z upon del x del y is equal to this. Further we have to find, differentiating del z upon del y with respect to x. From here, that is when differentiating del z upon del y with respect to y, with respect to x, taking minus of 1 plus of log y is constant. That is further we have to write, that is del 2z upon del x del y is equal to, here is y is taken constant because x is the function of z, so we have to differentiate 1 plus of log z only. First we have to write minus of 1 plus of log y is constant, and we have to differentiate del upon del x with that is 1 upon of 1 plus of log z. Further we have to differentiate, that is minus of 1 plus of log y, and we have to take 1 plus of log z into numerator, that is del of del x into 1 plus of log z e power minus of 1. We have to differentiate, that is we can also write minus of 1 plus of log y, and if using the formula, that is x की power n dy dx, that is nx n minus 1, using the formula, that is again here is minus is already present and we have to take minus back, that is minus of 1 plus of log z and nx n minus 1, and minus of 1 and minus of 1 into minus of 1, and again differentiating log z with respect to x, that is 1 upon of z, and z is the function of x, so we have to put del z upon del x. Further we have to arrange, that is del 2z upon del x del y is equal to minus minus is plus, that is 1 plus of log y into 1 plus of log z, 1 plus of log z की power minus 2, and we have to taking 1 second into denominator, that is 1 plus of log z का power square. Here is the minus of 2 taken into denominator, that is plus of 2, and the remaining is here, that is 1 upon z, 1 upon z, and putting the value of del z upon del x, and del z upon del x is given by minus of 1 plus of log x, 1 plus of log x upon 1 plus of log z. Further we have to write, that is once again 1 plus of log y and 1 plus of log x, that is minus of 1 plus of log y into 1 plus of log x upon, here is 1 plus of log z and 1 plus of log z का square, that is, and z 1 plus of log z का whole cube. Further we have to solve using the condition, that is del 2z upon del x del y is equal to, given here, that is minus of 1 plus of log y into 1 plus of log x upon z 1 plus of log z की whole power cube. In the given question, condition is given when we have to show that del 2z upon del x del y is equal to minus of x log e की power ex की power minus of 1 when x is equal to y is equal to z. So we have to put here condition put, that is x is equal to y is equal to z, that is further, that is we can write del 2z upon del x del y is equal to, we have to put in place of y, that is x minus of 1 plus of log x and 1 plus of log x. In the denominator we can also put in place of z, that is x, and in place of z we can also put x, that is 1 plus of log x the whole power cube. Further we have to cancel out, that is 1 plus of log x and 1 plus of log x, that is 1 plus of log x ka whole square and 1 plus of log x ka whole cube. Cancel out, then remaining is here, that is x 1 plus of log x. Further we have to write, that is x 1 plus of log x is taken into numerator, that is minus is already present, that is x 1 plus of log x की whole power is minus of 1 taken in numerator, and we have to show x log ex. Further we have to know the value of log e. The value of log e is 1. So we have to put in place of 1 log e, that is minus of x. In place of 1 we have to put log e and plus of log x की whole power minus of 1. We know that log m plus log n is written as log mn, so we have to write, that is del 2z upon del x del y is equal to minus x, and log m plus log n is written as log mn, that is log of ex की whole power minus 1. X log ex की power minus. This is the proving. This is the required solution of the given problem. Thank you class and thank you for watching.